Hello everyone and welcome to lesson 731, how can I use an equation? So today we're going to be dealing with scatter plots and creating equations so that we can use them and make a prediction. So primarily, can I find the slope on a graph? Now, slope on a graph, we have to use coordinates. We have to figure out how much it goes up, how much it goes over. We're also going to need to use the beginning value, the y-intercept today. But there's a trick today. Do I know where to put the dependent variable? There's always the independent on the x-axis and the dependent on the y. And today's problem is a little bit different, and oftentimes people get tricked. So here we go. Areli's bike ride. To prepare for a 30-mile bike ride for charity, Areli has been biking every weekend. To predict how long the charity event will take her to complete, Areli has been keeping track of her time and distances. She tries to ride at a constant pace, but of course, that is not easy to do. Would a box plot, scatter plot, or histogram be most useful in helping Areli make a prediction? Now, a box plot is used to show how spread out the information is. If we were looking at a histogram, right? This is a circle, a pie chart, and down here is a bar graph. A bar graph is very similar to a histogram, okay? And bar graphs and histograms, slightly the same, slightly different, but is this going to help us make a prediction? The answer is no, it is not. So, of course, we need a scatter plot. Down below the information and the scatter plot, you'll have like 4 lines. On that line, letter A. Scatter plots are best used to make predictions. Scatter plots are best used to make predictions. Okay. Question letter B. Considering that Areli is trying to predict how long, that is the question, how long. Well, which of those is how long, not distance. She's talking time. We want to know, question mark, how much time to go 30 miles. I know 30 miles. I don't know time. Okay, we're trying to use the graph to make that prediction. Okay, so which is the independent and which is the dependent before we make our scatter plot? Well, notice we have 3 columns. We have weekend, time, and distance. And which of this information is not needed? Well, if I'm trying to make a prediction about time and distance, do I need what weekend? No. Go ahead and put an X through that data because we don't need to know what weekend she was biking. That does not help us make the scatter plot. Okay? Now, in this problem, which is the independent and which is the dependent? On your lines down below, I want you to write, in this problem, distance is the independent variable. In this problem, distance is the independent variable, and time is the dependent variable. Now, this is the cause and effect. See, the cause is 30 miles. The effect is we're going to find out how much time it is. Okay? The distance is the independent, and the time is the dependent. So on your scatter plot, I want you to notice that we have distance on the x-axis. Notice on the x-axis I scaled my graph by 2s. And notice on the y-axis I counted by 10s for time. I want you to pause your graph or your video now to scale your graph and plot those 7 points. Please remember distance, that's sideways, and time is up. Go ahead, scale and graph. Okay, welcome back. You have plotted each of these points, and your graph should look something like this. Okay. Now, what we need to be able to do is take this information and we need to create a line of best fit, so that we can find the slope, so that we can find the y-intercept, okay? We're going to go through this. Now, you need a straight line maker, and I want you to please circle this coordinate and this coordinate, okay? This is coordinate 25, 150, and this is the coordinate 11, 80. Circle those two coordinates, okay? And let's go ahead and draw a line of best fit. Oh, line of best fit. My line of best fit looks something like this. Go ahead and make yours match. Pause the video to make sure that yours matches now. Okay, here we go. Now that pretty much completes the information that I need for problem 87. Okay. Down below you have problem 7-88. Okay, and then it's A, B, C, and D. Right? Now, problem 788A is asking choose 2 points to find the slope of the line. So I want you to record these 2 points. 25, 150 and 11, 80. And what we need to do is we need to find the slope of this line. Now, if you were using your graph, we could draw a stair. Okay? Now, if I am using this problem to figure out slope, now some of us make mistakes when we're counting because you count 1, 2, 3, 4, 5, 6, 7 boxes. But is that how much it went up? How much do you have to go up from 80 up to 150? It's not 7. Oh, remember we counted by tens? It goes up 70. So my slope is 70. Notice 150 take away 80. The difference is 70. That's helpful. Okay, now how much did I go over? Right here I'm at 11 and I end up at 25. How much do I go over? Well, some of you are going to count. Some of you could subtract. And I'm going to get 14. Now, if you have a calculator, boopity boopity boop, I'm going to get 5 minutes to go 1 mile. Remember, that is the question that we need to know. What is the rate? How many minutes in 1 mile? You've heard people say, oh, how fast do you run the mile? Personally, I could run like an 8-minute mile right now. In junior high, my best time was probably in the 7-minute mile. I was never a fast runner, right? But people want to know, how long does it take you to run this distance? Okay. Oftentimes people switch it around. How fast can you run? Miles per hour. Okay. This problem is a little bit different. We're switching our variables. So notice we have 5 minutes per mile. Question letter B. What is the y-intercept in this problem? Well, I notice my line goes all the way down to here. So I notice that my y-intercept is 0, 20. Now in this problem, what does that mean? Because shouldn't this be a proportional relationship, Mr. McCoy? Shouldn't you have 0 times, so you go 0 miles, or you have 0 miles, it takes you 0 time? Well, remember, on average, this is taking in all of the information. And when Aurelia is going for a bike ride, she rides, but she takes some breaks, right? She must have just gone up this really big hill, and she got to the top of the hill, and she's like, oh, I'm going to take a break. And when you take a break, time is going, but distance is not. Okay? I want you to write a sentence with problem letter B. This means, after you write 0, 20, this means Aurelia takes a 20-minute break and travels 0 miles. This means Aurelia takes a 20-minute break and travels 0 miles. Okay, let's go ahead and write the rule of this problem. Problem letter C is asking for a rule. Okay, when I'm asking you for a rule, you should be thinking the equation of a line, y equals blank x plus blank. Fill in those blanks right now. Pause the video, fill in the blanks. Okay, you know the slope is 5. The beginning value is 20. There is the equation of this line. Problem letter D. Problem letter D is saying, let's go ahead and answer the question. If we know the rule, y equals 5x plus 20, how long will it take if the bike ride is 30 miles? Well, let's do the math. Y equals 5 times 30 plus 20. And you go through the order of operations. The order of operations says multiply first. 5 times 30 is 150. 150 plus 20, 170 minutes. Now, this is a problem from beginning to end. We had this word problem. We had to think about independent and dependent variable. We had to think about how to scale our graph. We had to think about plotting points. We had to think about line of best fit. We had to think about the slope. We had to think about the beginning value. We had to create the equation of the line, and then we had to use the equation of the line. Man, this problem was intense. It had everything there. That's what I'm asking you to be able to do. And guys, I'm not saying this is easy, but I'm saying this is 8th grade math. This is used to predict real stuff, whether it's economics or health or government or small business. People use scatter plots all the time to predict the future. And the more accurate they are at predicting the future, the better off they are. Now, you might not think that you're going to use this in real life, but you need to understand how it happens and why it happens. So let's go to our last problem today. Whoop. Westland Workers Health and Wellness Department started a voluntary lunch program, lunchtime running club. Members kept track of how much they ran each week for exercise and how much their resting heart rate dropped over several weeks. Their data is in the table at right. Note that a negative heart rate change is actually a gain in heart rate. So there are people that started running, and the more you run, your heart rate gets used to that. And so people who averaged long distances, and this is how much their heart rate changed. Okay, so you're looking at a change in heart rate. So here's what you're going to do. You are going to do these things on your own. I am not going to give you all of it. Make a scatter plot. Off to you in the bottom left-hand corner, you need to make a scatter plot. You need to describe the association. Is it increasing or decreasing? You need to draw a line of best fit. You need to, using the line of best fit, you need to tell me what is the slope, what is the y-intercept, and that's going to tell you the line. Y equals, okay? Now, once you get the equation, predict the heart rate change for an employee who ran 10 miles. So if you are doing this, you're going to have y equals blank x. It's going to be a minus is your beginning value. Your beginning value is going to be down here somewhere, just so you know. Okay? And then you are going to plug in the value 10 to figure it out. So this is a problem just like the previous one. You're going to go through the whole thing beginning to end. Just so you know, law of significant figures. When you are done, you need to make sure that your growth is either a whole number or to one decimal. Round it to the tenths place. Okay? It's totally fine if it's in the tenths place. So, thanks for coming today. Do your best to complete this problem on your own. I know it's challenging, but this is what we're asking you to do. Plot the points, line of best fit. Oh, and there's an outlier. Ignore that outlier down there. I almost forgot. There's an outlier that doesn't fit the data, so ignore it, okay? So plot the points. Ignore the outlier. Draw a line of best fit. Find the slope. Find the beginning value. Give me a line. And find the value if a person runs 10 miles. Good luck and thanks for coming. We'll see you next time.